This exercise is going to have us play with two-dimensional arrays, dynamically allocated actually two-dimensional arrays. So we are going to write a bunch of functions which are going to allow us to offer an API for people to use dynamically allocated two-dimensional matrices. So this first page here explains to you what kind of files we're going to handle. This part should be like relatively standard by now, since we use the same organization for all of our mini libraries. Then we're going to discuss how internally those dynamical library will be represented. And the only thing really to understand here is that, well, if this is a matrix that you want to represent, I think I said library instead of matrix, sorry about that. If this is a matrix you want to represent in memory, you would just allocate, in this case, a 6 integer long dynamical array, and then you would manage the content so that this element here corresponds to element index 00, this one 01. So the first row is going to be stored first, then the second row, etc. So that means that to be able to access any element using the matrix start address as a referential, if you have the address of element 00 right here, you should be able to apply this formula, the start address plus x times the size of an entire row, starting numbering x at 0, plus y times the size of an int to locate the int inside of the row. And that would allow you to use this linear single-dimensional array as a two-dimensional matrix. So we are going to implement the functions that are doing exactly this, okay? And we are going to, if needed, add functions to be able to handle exactly what we need to do in those functions. So these functions here are the visible ones, and then we'll see if we need to add something as we progress. So we're going to get started with allocation, and the allocation, this should be like relatively easy. So I'm going to open, I already prepared the boilerplate code, okay? This is matrix.h, pound if and def, pound define, and then the prototype of all of our function. This is the matrix.c, with the body of the function already empty there, and this is test.c, with right now not much being tested at all. So let's go in the matrix.c and try to implement the allocate function. I'm given a number of rows, a number of columns. I'm going to start computing the size of the array I will have to allocate. That's going to be easy, number of rows times the number of columns. Then I'm going to make a dynamical allocation. So I'm going to call malloc using the size of an integer, size of one of the elements, time the number of elements total I need to allocate. And then I'm going to have to verify that my allocation went okay. So if p is actually equal to null, I'm going to simply return null. Okay, first error case that I'm handling. Actually, I'm going to go back here and I'm going to try to handle over error case. For example, if nb rows is lesser or equal to 0, return null. If nb columns is lesser or equal than 0, I return null. So I get rid of the obvious errors that can happen with this kind of code. If p equal null, return null, the allocation didn't go through. If the allocation went through, well, I'm ready to use this newly allocated matrix. So I'm going to return the address that I got in p. And this does it for the allocation. In order to make sure that my code is syntactically correct, I'm running a quick GCC. No problem there. I'm going back to matrix.c, and before I start testing, I'm going to take care of the deallocation, since we already took care of this kind of function in the previous exercise, and they should be relatively straightforward. Obvious case, if data equal null, return, well actually I don't have anything to return here. As you can see, the exercise didn't ask me to return any code, okay? Error code or whatever to indicate that the operation went smoothly or not. So what I'm going to do as soon as I get back my cursor here, I'm going to just return from the function. I just don't do anything, okay? So hold on a second, there's a little bit of delay here. Okay, we're back online, there was a little delay there. So what I was saying is that if data equal null, I'm not doing anything. Up, there we go. Otherwise, if data is different than null, then I can deallocate it, and I'm going to do so by just calling free and passing as parameter data. In the case of the clean deallocation, well, same thing. If data equal null, I'm not doing anything. So return statement by itself. If data is not null, then I'm going to try to deallocate by using my deallocate function here on star data, and it will check if star data is null, etc. If, well, pretty much your allocation is not going to tell me if it went fine or not, so I just stop here. So you have a different design here, okay, and you can see why sometimes there is a point in trying to systematically return an int, at least from your function, to serve as an error value, pretty much an error return value, to indicate if everything went fine or not. If you are using different language like Java, you will obtain the same effect by using exception. Okay, here we are really using the most primitive way of checking if things went okay when calling a given function or not. Okay, so we are done with this. Let me save. There we go. And I'm going to go now to test.c, and we're going to play a little with this function. Let's start by renaming here this test something boilerplate code into test dynamical. We'll call it from here. That's dynamical, test the allocation and deallocation of memory. What do I need here? I need a pointer at some point, that's for sure. And then I'm going to call my allocate function, and I'm going to test different possibilities. Okay, I need to pass rows and columns. So here we go. We start like the enumeration. What if I give you like, I'm going to assimilate together 0 size or negative size, okay? So what if I give you a negative colon? What if I give you, I'm going to cut and paste this to speed up the development of those tests. I give you then a null or negative row. And what if I do both the row and the column negative? Okay, so 3 different tests. Let's start with the first one. What I'm expecting is if p should be null. So if p is different than null, then printf error, and I'm going to indicate which situation triggered the error. There we go. Now that I have this printf, this if and printf, I'm going to reuse them. Oops, not here, but oh, I did a boo-boo here. All right, let me address this in 1 second. This curly brace here should be here. There we go. That's going to make a little bit more sense. So after this first case, I'm going to address the second case, which is the same thing. I'm trying to make sure that a null value is not going to be interpreted, and then I end up by coding with 0 for both dimension of my matrix. Okay, so I have those things taken care of. Let me go back to see the code of my my function. Is there anything else I can pretty much mess up by passing wrong parameters? No, I think I tested everything. Now what I need to do is test the case where it's actually supposed to work. So I'm calling allocate, and I'm going to ask, well, let's use the same example that we had, okay? 2 rows, 3 columns. And I'm going to check this time that if p equal null, then I have a problem with the allocation of a valid matrix. Cannot allocate to free matrix. Let's save. We're going to go back to Conqueror. I'm going to compile again. A couple of little issues here. Warning, implicit declaration of test dynamical instead of dynamical. So I just made a typo when I invoked the function here. Let's save. Once again, compile. This time it's working fine. A.out, no error detected. Okay, so we took care of this first part actually of this exercise.